right, get this. We're going deep today. Quantum computing, but not the stuff you probably heard about already.
Right.
You guys sent in some wild articles and videos on, get this, Microsoft's Majorana 1 chip.
Yeah.
And the tech world is seriously buzzing.
It's exciting stuff.
It's being called the world's first quantum processing unit, QPU, powered by a topological qubit, whatever that is.
And that's what's really interesting here, I think, is this completely different approach that Microsoft is taking compared to other companies working on quantum computers. They're using a new type of material called a topo conductor to make these qubits.
Conductor. Okay, that sounds like, I don't know, Star Trek? Break it down for me. What's so special about this material?
It might sound futuristic, but it is very real. Imagine a material that can conduct electricity perfectly without any resistance, even in crazy cold temperatures. That's what a topo conductor can do, and it's this property that makes Microsoft's approach so intriguing.
So they're using this special material to build their qubits.
Yeah.
But, like, how? Do they just wire it up and boom, quantum calculations?
Not quite that simple. To create these special qubits, Microsoft had to engineer these topo conductors by combining a semiconductor and a superconductor. And then, get this, they have to cool it down to near absolute zero.
Whoa, whoa, whoa. Absolute zero. How cold is that?
We're talking colder than outer space.
Colder than outer space.
Oh.
Okay, so what happens at those temperatures that makes these topo conductors tick?
All right, that's where it gets really, really interesting. At these super low temperatures, and with some carefully applied magnetic fields, these materials exhibit something called topological superconductivity.
Okay. Before we get lost in the quantum weeds, can you give me the layman's version?
Sure.
What's so special about topological superconductivity for building a quantum computer?
Think of it like this. Inside these topo conductors, at these ridiculously low temperatures, special quantum particles called Majorana zero modes, or MZMs, they pop up. These MZMs are the key to Microsoft's qubits.
MZMs, all right. So these MZMs, they're what makes up their qubits, right? But why are they any better than the qubits other companies are using?
That's a great question, and the magic of MZMs really lies in how they store information.
Okay.
You see, traditional qubits are very sensitive, easily disrupted by any kind of environmental noise. But MZMs are way more stable, and that's because they store information differently. By encoding it in something called parity, which you can think of as like a quantum coin flip representing zeros and ones.
So it's like having a super robust quantum bit that's less prone to errors. That seems like that could be a huge advantage, right?
Huge. You got it. That inherent stability, that's been one of the biggest hurdles in actually building useful quantum computers. So if Microsoft's claims actually hold up, this could be a real game changer.
Okay, I'm starting to see why everyone's so excited about this. But how do they actually, like, control and manipulate these MZMs to do calculations? It all sounds super complex.
You'd think it would require some incredibly intricate method, right? But Microsoft has come up with a really elegant solution using something called measurement-based quantum computing.
Right.
So instead of using complex analog signals to manipulate the qubits, they use simple digital pulses and tiny semiconductor devices called quantum dots.
Hold, are you telling me they are controlling these, like, ultra-delicate quantum states with something as simple as an on-off switch?
Essentially, yes.
Wow.
They connect and disconnect these quantum dots to the nanowires, where the MZMs live, to measure the parity and, in effect, change the qubit's state. And this digital control makes it way simpler to manage and scale up the system. Plus, it makes error correction much easier, which is, crucial for building a quantum computer that actually works reliably.
Sounds like they've tackled some of the biggest challenges in quantum computing all at once.
Absolutely.
You mentioned scaling up.
Yeah.
How do they go from these, like, individual MZMs to a full-blown quantum computer?
So that's where the idea of tetrons comes in. Think of a tetron as a single qubit building block made up of two of these nanowires with MZMs at their ends. Microsoft's plan is to connect these tetrons together like tiles. Starting small and gradually building larger and larger arrays.
So they are literally building a quantum computer brick by brick using these tetrons.
That's the idea.
This seems like a completely different approach compared to, what we've heard from other companies. 1 million qubits on a single chip. Is that even possible?
That's the ultimate goal, and they envision getting there step by step. They're starting with smaller arrays. But their roadmap, it aims to reach a system capable of handling 1 million qubits. Imagine the kind of problems we could solve with that kind of computing power.
1 million qubits. That's just mind-blowing. But let's be realistic here. Is that even necessary? Like, what could we do with 1,000,000 qubits that we couldn't do with, let's say, 1,000?
That's a great question, and it gets to the heart of why this breakthrough is so significant. 1,000,000 qubits could unlock solutions to problems that are simply impossible for even the most powerful supercomputers today.
Like what? Give me an example.
We're talking about designing revolutionary new materials,
Okay.
discovering life-saving drugs, maybe even unlocking, the secrets of the universe.
Okay, I have to admit, that's pretty exciting stuff. But before we get too carried away, I think we need to, dig a little deeper into how realistic this all is. What are the biggest hurdles Microsoft still needs to overcome to make this 1,000,000 qubit dream a reality? What could potentially go wrong along the way?
Those are excellent questions. And it's important, like you said, to temper our excitement with a dose of reality. Building a 1,000,000 qubit quantum computer is a monumental task. There will undoubtedly be challenges along the way. One of the biggest hurdles is maintaining the stability of these MZMs as they scale up the system.
So even though MZMs are more stable than other qubits, there's still a chance they could, become unreliable as they build larger and larger systems.
Exactly. Think of it like building a house of cards. The larger it gets, the more precarious it becomes. Maintaining the delicate quantum states of 1,000,000 qubits is going to require incredibly precise control and error correction.
So what could go wrong?
Mhm.
What are the potential pitfalls they need to watch out for?
Well, one concern is that unforeseen technical challenges could arise as they scale up.
Right.
Maybe they'll encounter unexpected interactions between the qubits, or the error correction methods might not be as effective as they anticipate. There's also the risk of external factors, like unexpected noise or vibrations that could disrupt the delicate quantum states. These are all challenges that Microsoft and other researchers in the field are actively working to address.
So even with this breakthrough, there's no guarantee of success. It sounds like there's still a lot of work to be done before we see a 1,000,000 qubit quantum computer in action.
Absolutely. But that's the nature of cutting-edge research, It's a journey of exploration, and there will be setbacks and surprises along the way. The important thing is that Microsoft has made significant progress in addressing some of the fundamental challenges of quantum computing. Their approach seems promising, and if they can overcome these hurdles, it could truly revolutionize our world.
All right, so it's a mix of cautious optimism and genuine excitement. This is definitely a story we'll be following closely. But before we move on, there's one thing I'm still a little fuzzy on. You mentioned earlier that Microsoft is working with DARPA on this project. Wait, DARPA, as in the agency that's responsible for developing cutting-edge technologies for the military. What are they doing with quantum computing?
Yes, you heard that right. DARPA has a keen interest in quantum computing, and that's because they recognize its potential to transform various fields, including, as you said, national security. They've partnered with Microsoft to help accelerate the development of this technology, and that involvement, it speaks volumes about the potential they see in this approach.
Wait, DARPA is involved. That's the agency that practically invented the internet. Their interest, it suggests this isn't just hype.
Right.
The government sees some serious potential here. What exactly are they hoping to achieve with this collaboration?
Well, DARPA is providing funding and expertise to help Microsoft build a working prototype of this fault-tolerant quantum computer. Their goal is to create a stepping stone to a fully commercial system, and they believe it can be achieved in a matter of years, not decades.
Wow, that's incredibly ambitious. It sounds like this technology is advancing way faster than many people expected. This whole thing is starting to feel like a science fiction movie come to life. But before we get lost in visions of the future, let's bring it back to the present. We've covered a lot of ground in this first part of our deep dive, but there's still so much more to explore.
There is indeed. And what's particularly fascinating is that this breakthrough is generating buzz far beyond just, the world of quantum physics.
Right.
Experts from all sorts of fields, cybersecurity, material science, even agriculture, are starting to weigh in on the potential impact of this technology.
That's a really good point. It highlights just how wide-reaching the implications of quantum computing could be. It's not just, a niche technology for scientists and engineers. It has the potential to touch every aspect of our lives.
Precisely. And what's even more interesting is that Microsoft isn't putting all their eggs in one basket. While they're heavily investing in topological qubits, they're also maintaining partnerships with other companies working on, different types of quantum computers.
So they're hedging their bets, so to speak.
Yeah.
That's a smart strategy, right?
It is.
It acknowledges that the field of quantum computing is still evolving, and that there's no guarantee which approach will ultimately prove to be the most successful. But it also suggests that they're confident enough in this topological approach to make it a central part of their strategy.
Exactly. And it also reflects the collaborative nature of the field. Companies are working together, sharing knowledge and resources, to advance the state of the art. It's a testament to the shared vision of creating a future where quantum computers can solve some of humanity's most challenging problems.
It's inspiring to see that level of collaboration and dedication. It really
Yeah.
feels like the whole world is working together to unlock the potential of this amazing technology. But speaking of potential, we've talked a lot about the positive side of things, but what about the potential downsides? We touched on cybersecurity earlier, but are there other risks or challenges that we need to be aware of?
One concern that often comes up is the potential impact on jobs. As quantum computers become more powerful, they could automate tasks currently done by humans, which could, unfortunately, lead to job losses in certain sectors.
That's a valid concern. Automation has always been a double-edged sword, bringing both benefits and challenges. But I wonder if the same could be said for quantum computing.
Right.
Perhaps we'll create new jobs in industries that we can't even imagine yet.
That's definitely a possibility. Just as the internet created countless new jobs and opportunities that didn't exist before, quantum computing could spark a wave of innovation that leads to entirely new fields of work. It's all about adapting and evolving with the changing technological landscape. And who knows, maybe some of our listeners will be the ones pioneering those new industries.
Now, that's an exciting thought. It's a reminder that we're not just passive observers of this technological revolution. We have the power to shape it and create the future we want to see.
Absolutely. And that's why it's so important to have these conversations, to educate ourselves about the possibilities and challenges of quantum computing, and to engage in thoughtful discussions about its implications. We need to be informed and engaged citizens if we want to harness this technology for the greater good.
I completely agree. Knowledge is power, and the more we understand about quantum computing, the better equipped we'll be to navigate this exciting and uncharted territory.
Welcome back to our deep dive into this fascinating world of Microsoft's quantum leap.
It's wild to think we're already at a point where something like quantum computing is even possible.
Just, a few decades ago, the idea of using quantum mechanics to build a computer would have sounded like, I don't know, pure science fiction.
Right.
And yet here we are on the cusp of this whole new era of computing.
Before the break, we talked about how this new tech could impact jobs, like both the good and the bad.
Yeah.
The possibility of job losses from automation, but then also the creation of brand new types of work we can't even imagine yet.
It's a crazy paradox, isn't it? This one technology could shake up existing industries while also creating so many new opportunities.
It's almost like trying to predict what will happen when you drop a pebble into a pond.
Yeah.
You see the initial splash, but then the waves, they just keep spreading, creating these unpredictable patterns.
That's a great analogy.
Yeah.
And just like with the internet, it's often those unpredictable ripples that lead to the biggest changes. Who could have predicted social media or, I don't know, e-commerce when the internet first came out?
Exactly. And that's what makes all this so exciting. We're talking about technology that could totally change our world in ways we can't even wrap our heads around.
To get a better sense of what that future might look like, I think it's helpful to explore some specific areas where quantum computing could really make a difference.
Okay, so let's get specific. What are some real-world applications where this technology could actually make a tangible difference?
Well, one area that's generating a lot of buzz is material science.
Okay.
Imagine being able to design materials with properties that were once thought to be impossible.
Like what?
Self-healing materials,
Hmm.
ultra-efficient solar cells, even fabrics that can change color on demand.
Wait, hold on. Self-healing materials. Are you saying we could have bridges that repair their own cracks? Or buildings that can, like, adapt to earthquakes? That sounds like something straight out of, I don't know, a superhero movie?
It might sound crazy, but that's the kind of potential we're talking about here. Quantum computers could revolutionize how we design and create materials by simulating, like, the behavior of molecules and atoms with incredible precision.
So instead of doing trial and error in a lab, scientists could use quantum computers to just design materials from scratch, atom by atom.
Exactly. They could play around with different combinations of atoms and molecules virtually, testing their properties and seeing how they perform before even trying to make them in the real world.
That's amazing. Yeah. It's like having a virtual lab where you can test out all these wild ideas without the limits of the physical world.
And that's just the start. Quantum computers could totally change drug discovery, too, leading to quicker development of new treatments and cures for diseases.
This is all great, but I'm having trouble imagining how it impacts my daily life. Can you give me like a concrete example of how quantum computing could affect the average person?
Imagine a world where personalized medicine is just normal,
Okay.
where doctors can take your genetic information and tailor treatments just for you, making them way more effective in reducing side effects. Or picture a future where renewable energy is, plentiful and cheap because we figured out how to make super efficient solar panels using quantum simulations.
Right.
Those are just a couple of examples of how quantum computing could touch our lives in big ways.
Okay, yeah, I'm starting to see the bigger picture. This isn't just about faster computers. It's like a whole new world of possibilities is opening up.
Exactly. And that's why this technology is so powerful. It's not just a small improvement, it's a giant leap forward,
Right.
a leap that could give us solutions to problems we thought were unsolvable.
You said earlier, though, that we're still early in the development stage.
Right.
There's still a ton of research and engineering that has to happen
Mm-hmm.
before we actually see these applications out in the world.
That's true, but the progress we're seeing is really amazing. And it's not just Microsoft doing this. You have Google, IBM, Intel. They're all investing in quantum computing, and governments around the world are realizing how strategically important this is.
So it's like a global race to figure out quantum.
Pretty much. And it's not just about bragging rights or, who has the strongest economy.
Right.
There's a growing understanding that quantum computing could help us solve some of humanity's biggest problems, from climate change to disease.
So it's not just building a faster computer. It's using this technology to, like, actually make the world a better place.
Absolutely. And that's why it's so important to be having these conversations, to teach ourselves about the possibilities and the challenges of quantum computing, and to talk about what it all means ethically.
Speaking of ethics, you mentioned that quantum computing could mess with cybersecurity.
Yeah.
Can you explain that? Like, why is that such a big concern?
So think about this. A lot of our online security relies on encryption that's really hard for normal computers to crack. Quantum computers, though, could potentially blow right past those codes in no time.
So if these quantum computers actually happen, are all our online passwords just going to be useless? How do we even protect ourselves in a world where these machines can just crack any code?
That's the challenge, and security experts are working like crazy to figure it out. They're trying to come up with new encryption methods that can stand up to quantum attacks. They're calling it post-quantum cryptography.
So it's like a race against time. We need to figure out these quantum-proof safeguards before these super powerful computers end up in the wrong hands.
You could say that.
Yeah.
And it shows how important it is that we develop and use this technology responsibly. We need to make sure quantum computers are helping people, not hurting them.
Okay, so there's a lot to consider here.
For sure.
Both the good stuff quantum computing could bring and the risks we need to deal with.
Absolutely. As we move towards this, quantum future, we have to have these talks, think about the ethical side of things, and work together to make sure this technology benefits all of humanity.
Well said. It's been amazing exploring the world of quantum computing with you today.
Yeah, I'm really enjoying it.
From the crazy science behind these topological qubits to how this tech could impact society.
It's been a real eye-opener. I'm glad.
But I think we need to take a short break here.
Sounds good.
When we come back, we'll look at some of the specific ways quantum computing could change our lives and what the future holds for this groundbreaking technology. Stay tuned. Welcome back to the Deep Dive. It feels like we've barely scratched the surface of what's possible with quantum computing.
I know, right? We've covered so much, from how Microsoft's topological qubits actually work to the potential impact on things like materials science and drug discovery.
And we can't forget about the cybersecurity stuff we talked about. The idea that quantum computers could crack the codes that keep our online data safe.
It's definitely something to think about, that with all this power comes the responsibility to use it for good. But for now, I think it's good to focus on all the positive things that could come out of it.
You said earlier that quantum computers could change agriculture. Can you tell me more about that?
Agriculture isn't exactly the first thing that pops into my head when I think of quantum mechanics. It might seem a little strange, but quantum computers could actually help us solve some of the toughest problems in agriculture today. Things like growing more food while minimizing the impact on the environment.
Okay, how would that even work? Are we talking about like quantum-powered tractors or something?
Not quite. Think more along the lines of Using quantum simulations to really understand the complex stuff happening in biology, like nitrogen fixation, which is super important for how plants grow.
Nitrogen fixation, that sounds familiar. It's like how some bacteria take nitrogen from the air and turn it into something plants can use, right?
Exactly. It's a crucial process for agriculture because nitrogen is one of the main nutrients that plants need. But the way we're making nitrogen fertilizers now uses a lot of energy and can be bad for the environment.
So could quantum computers help us find better, more environmentally friendly ways to make fertilizer?
That's one possibility. Scientists could use these simulations to figure out the complicated chemical reactions in nitrogen fixation and maybe design new catalysts that make the process more efficient, using less energy and producing fewer emissions.
That would be huge, both for farmers and for the planet. It's crazy to think that quantum mechanics could help us grow food in a better way.
It is, and that's just one example. Quantum computers could also be used to do things like make irrigation systems work better, predict plant diseases, even create new types of crops that are more resistant to pests or drought.
So it's like giving farmers a whole new set of tools to help them grow food for a growing population in a way that's good for the environment.
Exactly, and it really shows how quantum computing could change so many different industries.
We've talked a lot about potential, but what about the timeline? When are we actually going to see these things happening in the real world?
It's tough to say exactly when because things are changing so fast in this field, but a lot of experts think we could see some practical uses of quantum computing in the next 10 years or so.
So this isn't something our grandkids will be figuring out. It's something we might actually experience ourselves.
That's the exciting part. We're not talking about some distant future. This technology is almost here, and it has the potential to change our world in ways we can barely imagine.
It feels like we're standing on the edge of something totally new, looking out at a future full of possibilities, but also a lot of unknowns.
And that's exactly what drives so many people working in this field. They want to understand the mysteries of the quantum world and use that knowledge to make things better for everyone.
It reminds us that science, at its heart, is all about exploration, discovery, and pushing the boundaries of what we know.
Absolutely. And you could say that quantum computing is one of the most exciting frontiers in science today. It's giving us a peek into a world where things we thought were impossible might actually be possible.
Well, this has been an incredible journey for me, and I hope our listeners feel the same way.
I think we've given them a lot to think about and a lot to learn more about.
And as always, we want to hear from you. Tell us what you think on social media, check out the resources on our website, and keep that curiosity about quantum computing alive.
Thanks for taking this deep dive into Microsoft's quantum leap with us. Until next time, keep exploring and learning, and who knows, maybe you'll be the one to make the next big discovery in this incredible field.